Hi there, today we're doing May-June 2020 paper 42. Let's go. Question 1, stem and leaf diagrams. Right, so here they've already done the first one, 17, they've put it in there. Now remember, it has to be ordered, always in the right order. So before I put the numbers in the stem and leaf diagram, I'm just going to organize them and then order them. Also, it's best to do it one by one to make sure you don't leave anything out. So 21, the 1 will go in this row, and then it's another 21, 18, 23. Once we got them sorted into the 10s and 20s, now we can put them in order. And there we go. That's how you do it accurately. Make sure you don't make any silly mistakes, because this is an easy 2 marks. Next, the median is of course the middle number. Now there's different ways of finding the middle number. Doing it with maths is you take the number there are 15 values here. We add 1 and then divide it by 2, which will give us 8. That means the 8th value is the middle value. So let's count that. Let's find the 8th value. So this is first, second, third, fourth, fifth, sixth, 7, 8th. This will be the middle value. Let's see if it's right. There's 1, 2, 3, 4, 5, 6, 7 smaller, and there's 1, 2, 3, 4, 5, 6, 7 bigger. Clearly that is the middle. So the median is 1. No, of course not. That is 21. Remember, that 1 doesn't stand for 1, it stands for 21. Right, the upper quartile is the top 3 quarters, or half of the upper half. All right, so if we look here at the half of the upper half, you see here, this is the upper half. So there we got 1, 2, 3, 4, 5, 6, 7 numbers. Which one is in the middle? This one here. Because now we can see there's 3 smaller and 3 bigger. And that is, of course, not 3, but 23. That's the upper quartile. And we've done it. Right. Part 4. A pie chart, of course, is always 360 degrees. And to find the sector angle, we need to know what fraction of that 360 it is. So it's going to be a fraction. Okay, a fraction out of what? The total number. There were 15 values, remember? And that's stem and leaf diagram. Okay, how many of those is 18 degrees? There's 2 of them. So 2 out of 15, that will give us the fraction out of 360. So we grab our calculator, save time, gives us 48 degrees. That will be the sector angle. Pie charts is just fractions. Question 1b, Boxer whisper plot. The median, of course, is that middle line in the box. Alright, we need to make sure that we get the scale right though. Alright, so let's see, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares between 100 and 150. So every second square needs to count for 10. Or every square counts for 5. So that's 110, 120, 130, 120 grams. The range, now this is not the interquartile range, the range is from the stretch of the whole thing. The biggest value here, which is 170, and the smallest, which is 40. So our range will be 170 minus 40, which is 130. Interquartile range, of course, is the stretch from between the upper and the lower quartile. So the edges of our boxes. Okay, the upper quartile here being 140, and the lower quartile being, what's that, 60, 70, 80. Yeah, 80. So that's 140 minus 80 gives us 60. Make sure your zeros looks like a 0 and not like a 6. Well done. Question 1C part 1. They want us to calculate an estimate of the mean. Alright, this is about the time it took students to complete homework. Yes, so 6 students took somewhere between 40 and 60 minutes to do the homework, and the 30 students working maybe the hardest took between 100 and 150 minutes. Okay, we don't know the exact time it took each student to complete their homework. It's been grouped, so that's why this is an estimate. Now remember, mean means that we need to add everything together and divide them by how many there is. So adding together what? What are we adding together? We're adding together all the time these 200 students spent on their homework. Meaning, these first 6 students, okay, how long did they spend on homework? We don't know exactly, so we're going to take the average, an estimate. Between 40 and 60, the middle is 50. So those 6 students, on average, we estimate spent 50 minutes doing their homework. So we need to add up all those 50 minutes 6 times, or just 6 times 50. And that's what we're going to continue doing now. We add that to the next 10 students who spent roughly the midpoint there 70 minutes doing their homework. And that pattern we continue. Right, just in case you have trouble finding the midpoint, there's a method. Of course, you take the two endpoints, add it together, and divide it by 2. So if you do that, 100 plus 150 divided by 2. Alright, this is relatively easy for this one. Sometimes it's a bit harder, and that's how you find the midpoint. Okay, that will give us the total time all the students added together spent on their homework. Okay, mean that means we need to divide it by the total, in this case, the total amount of students, 200. So let's put that into our calculator. And I get 93.4. Okay. Next thing, check, does your answer make sense? Where does 93.4 fall in my table? 93.4 will be around about here. Okay. Is that roughly in the middle? Yes, because the table is weighted more. There's 84 and 30 here. These numbers here are smaller. So 93.4 is roughly in the middle. So it is a viable answer. Okay, if we got an answer that was lying very low or very high, then we know we probably made a mistake. It's easy to press a plus or a minus when you shouldn't and then get it wrong. So I also recommend doing this calculation more than once. Here, the correct answer, 93.4, is correct. Question 1C part 2 is a little bit harder. Okay, first of all, we're talking about histograms. So remember the formula for a histogram. Always good to draw a triangle. What is the formula? For histogram, the frequency, which means the amount, is the frequency density times the class width. What does that mean? All right, remember now, if you got a stem and leaf diagram, on the vertical axis is where you have the frequency density. On the bottom axis, in this case, where we'll have the time. and the time here will have the classes. Okay, so one class will be 40 to 90, and the next class will be 150. So here the class width, CW, for the first class there is 50, and for the next one is 60. Right, now it tells us on a histogram the height of the bar for the 40 to 90 interval is 17.2 centimeters. I mean, on the histogram, looks like this. Then the height of the bar, I'm going to use a different color, how high this bar is from there to there is 17.2 centimeters. Okay, but what do we have in this bar? Well, we got the class width from 40 to 90 is 50, and we got the frequency 86. So we can use that to work out the frequency density. Okay, so we take the frequency for that first bar, which is 86, and we divide it by the class width, which is 50, and that gives us frequency density. 86 divided by 50 gives us a frequency density of 1.72. Now remember, the actual height of the bar, the physical height of the bar, is 17.2 centimeters. So actually, what have they done here? They've multiplied it by 10, made it a little bigger. Okay, so let's do the next part. Let's go back here. Calculate the height of the bar from 90 to 150. So what we have here, we got the class width and we got the frequency. So let's do the same. It's 114 divided by 60 equals, let's see, 140 divided by 60 equals 1.9. So before, when it was 1.72, the height was 17.2 centimeters. Now, what will be the height? Yes, of course, we times it by 10 and we get 19 centimeters. And that is the correct answer. Just what does it exactly mean? Well, let me make some space here. Okay. If I were to complete this stem and leaf diagram, which means draw the bar over here, the height of that bar there would be 19 centimeters. Even though if we go across, the frequency density here would be 1.72 and the frequency density of this one will be 1.9. And that's what we've just done. Well done. Question 2a, we got Alex. Let's just put A for Alex. We got Bobby and we got Chris. And the ratio of strawberries shared is 3. Alex gets 3 strawberries and Bobby and Chris each gets 2. So Alex gets more. He's the favorite. Then it tells us Chris received 12 strawberries. So in fact, he doesn't just get 2, he gets 12, which means he gets 6 more. Right, because the ratio between Bobby and Chris is the same, we multiply that by 6. Bobby also get 12, but Alex, we multiply that by 6, gets 18. So what is the total number of strawberries shared? Of course, is 18 plus 12 plus 12. 42. Hope to have some cream with that. In a sale, a shop reduces all prices by 12%. Now, this is always the same. When you reduce something by 12%, you take 100%. You take away 12% from that, and you'll end up with 88% of the original price, which is 0.88 as a decimal or a multiplier. That means if the original price of a book is $6.50, the new price will be 88% of that, and we get it by just multiplying by 0.88. So 6.5 times 0.88. There we go. $5.72 is what she pays. Question 2b part 2 though, we are working backwards. It tells us what Elu pays and they want to know the original price. So here as where we took the original price and we multiplied it by 0.88 to get the new price, which in this case is $11. We now want to know the original. So when we move backwards, we work backwards, we need to do 11 divided by 0.88 to get the original price. So let's do that. And that's $12.50. Does it make sense? Yes. And the original price was $12.50, it got reduced, and now that is the new price. Question 2c can be a little bit confusing, but we are going to do this. Ferry invests some money. Let's make up an amount. Let's say Ferry invests a nice sweet $100. Okay. So that means if the rate of interest for the first year is 2.5%, it gets increased by 2.5%, which is increase a total amount of 102.5%. But because we used 100, it means after the first year, let's just first year, Ferry has $102.5. Okay. At the end of the second year, the overall percentage increase of Ferry's investment is 6.6%. Okay. So the overall, which means from that 100 to there, 6.6%. So again, so that means Ferry's got $106.6. Now the question is, what is the increase from there to there? Okay, so first we work out the actual increase, which in this case, because we used $100, also the percentage increase. So we do 106.6 minus 102.5. So that means Ferry's investment increased by $4.1. Okay, now how do we work out the percentage increase? We need to take the actual increase and divide it by the original amount. And remember, the original amount here is at the end of the first year, which is 102.5. It increased from 102.5 to 106.6. And then, of course, times it by 100. And that will give us the actual increase. So 4.1 divided by 102.5 times 100. And there we get, that's a 4% increase. Okay, not sure if it's correct. Let's have a look. Okay, test the answer. Ferry invests $100. First increase it by 102.5%, which is a multiplier is 1.205, so that's 1.025. And then it increase the second here by 4%. So if we increase something by 4%, we end up with 104%, which is 1.04. So we do that, 100 times 1.025 times 1.04, bam, we end up with $106.6, which if it was a $100 investment would be a 6.6% increase. And we know we got it right. Question 2D, we're talking about an exponential rate, which reminds me of compound interest, okay, which is also exponential. The difference though here is we got decay, meaning we're going to use the same formula where the amount we want is the principal, the original amount, 1, and because it's decay, going less, we're going to put minus instead of plus the rate over 100, and then to the power of n, which is the time. So in this case, We want the final mass, the amount. Okay. The principal is what we start off with. We start off with 80 grams. 1 minus, because it's decay, the rate is 2%. And is decaying for 5 days. So let's put that into our calculator. And then we get a sweet 72.313, etc. Rounded to 3 significant figures is 72.3 grams. Part 2, find out how many more. The moment you see something in bold, don't forget about it. Whole days after day 5 it takes for the mass to reduce to less than 67 grams. Okay, so what we have? We now have the amount, total amount. So 67 grams we're looking at. Okay, I'm going to still start with the 80 gram original mass. 1 minus the decay is still 2%. What we don't know is what is the time. Right, now there are different ways to do this. I think the best is trial and error. Okay, on my calculator I still have what I've put in before. All I can do now is a little bit of trial and error. So just use the arrows, go back. Okay, that was 5 days. Let's substitute that 5 for a 6. Okay, 70. Remember now, we're looking to go below 67. Okay, so that's 6 days. After 7 days, we're at 69. Over 8 days, we're at 68. After 9 days, we're at 66. We just dropped between 67. So that means, okay, let's show that in our calculation. So what I've got on my calculator is 81 minus 2 over 100 bracket to the power of 9 equals 66.69, etc. So what 9 is that? N equals 9. Okay, remember what I said? There was something in bold. Don't forget about it. How many more whole days after the 5 days? So after the 5 days to get to 9 days, it's of course another 4 days. So it takes another 4 days for it to drop below 67. It's important that you do show your working out here though, okay, because they don't award the marks here, specifically on the mark scheme, says not from wrong working. So if they don't see the correct working out here, you're not going to get your marks. That is very, very important. Question 3a. Gita buys X apples. Then she buys some oranges, which is 7 more than the apples she bought. Then she buys some bananas, which is twice as much as the apples, minus 1 less. Okay. When she added up all these fruit that she bought, she saw that she got 30 pieces of fruit. How many apples did she buy? So let's solve this equation. Let's add up all the x's. 1x is 2x, plus not 2x is 4x. And 7 minus 1 is 6. Let's subtract the 6 from both sides. That gives us 4x equals 24. And to get x, then we divide the 4 on the other side. 24 divided by 4, x equals 6. X is also the exact amount of apples she bought, so that means she bought 6 apples. Okay. Then the cost of one apple is 15 cents. So if she bought 6 apples, we do 6 times 15, which is 90 cents. Let's put a C there, 90 cents. Okay. One orange is 18 cents. Now remember, the oranges is x plus 7. So that means she did 6 plus 7. She bought 13 oranges. Okay, so 13 times 18. Don't waste your time to do that in your head. 234 cents is what she paid for the oranges. Okay. So, and then there's the bananas. We don't know the price of the bananas. So let's make that a B for bananas. Right. So, well, we can work out how many bananas she bought. The amount of bananas she bought was 2x, so 2 times 6 minus 1. She bought 11 bananas. Okay, 11 bananas bought. So, there's the 90 cents she paid for the apples. There's 234 cents she's paid for the oranges, and then there's the 11 bananas, but we don't know how much she paid for them. In total, that was 555 cents. So to work out the cost of one banana, we first need to subtract this from the other side. So that means 11 bananas cost 231 cents. So one banana will be 231 divided by 11, 21 cents. It is a banana, which is a fair price for a banana, I guess. Depends on where it's from. Question 3b, part 1. Solving. Straightforward, this one. First thing we do, we add the 1 on both sides. That will give us 3w over 16 equals half plus 1 is 1.5, or 1.5. Let's go at 1.5. Okay. Next thing, we multiply the 16. So we got 3w 1.5 times 16, which will give us 1.5 times 16, of course, is 24. Last step, divide that 3. So w is 8. Okay. Don't be shy to do a quick test. Yeah, you do 3 times 8. I mean, this doesn't count marks. It just gives you peace of mind. Okay, on your calculator, 3 times 8 is 24. Divided by 16 is 1.5 minus 1 is a half. You know you got it right. And you feel good. Question 3b, part 2. Okay, let's do the same thing here. Okay, in fact, we can rearrange the whole thing and do it again, but if you look carefully, let's look very carefully here, yeah, that this and this is essentially the same. The only thing that has changed is that w there is now 2 to the power of minus 1. So it would be safe to say that w equals 2 to the power of minus y. Excellent. To make things even go quicker, we know w is 8. So we can write 8 equals 2 to the power of minus y. Now the magic here is going to be getting those base numbers the same. Okay. And we know that 8 equals 2 cubed. Because 2 times 2 times 2 is 8. So we can write 8 as 2 cubed. Now it's wonderful because the base numbers is both 2. That means 3 equals negative y. Okay, just get that rid of the negative, multiply it on the other side, divide it on the other side, whatever you want to do. That means y equals negative 3. Simple actually, isn't it? Question 3c part 1. Simultaneous equations, and they've lined up everything for us already. We got the P and the P, the Q and the Q, the equal signs, everything is lined up perfect for the elimination method. So it means we need to add or subtract these together. Okay, what we're going to eliminate there is the Q, because the coefficient in front of that is the same. Now, if we're going to subtract these two equations from each other, we'll get 2p minus p is p, and then we'll get q minus minus, there's two minuses, which means basically q plus q, which is 2q, which is not what we want. We want to eliminate it, we want the q to be gone. So then rather than subtracting them, we're going to add them, because that will give us q plus minus q, which is the same as q minus q, which will give us 0, and that's what we want. Okay, so remember, there's always plus or minus, but you can reason it out if you think carefully. So let's just do this from the start again. 2p plus p is 3p. Q plus minus q is the same as q minus q, is 0, it's nothing. And then 2 plus minus a half is the same as 2 minus a half, which is 1.5. 1.5, 1.5, or 3/2. Let's put 1.5. It's just a bit quicker for me today. Right. So the last step will be p equals 1.5 divided by 3, which gives us p equals a half, 0.5. Whichever way you want to write it, a fraction, a decimal. Mark scheme is a fraction. I'm putting a decimal. It says or equivalent, so that's fine. Okay, to get q, we need to substitute it back into one of the equations at the top. Which one shall we do? Let's do the first one, just because there's no fractions and there's no negatives, which should make it a little bit easier. So if p is a half, we do 2 times a half plus q equals 2. So 2 times a half is of course 1. Subtract that 1 on the other side, and q equals 1. Okay, you can check if it's right by substituting it back into that second equation. So this doesn't count marks, it's just for yourself to know you're doing stuff right. So we take the second equation there. P is a half, so that's 0.5. Q is 1, so that's minus 1. And what's a half minus 1? Of course, yes, it's minus a half. It's correct. We know it's correct. We've got our marks. Question 3c part 2. Right, and the first thing that throws my students off is that word hence. Okay, if you're not a first language speaker English, it might be a bit strange. Hence just means therefore, meaning it connects the previous questions. Use the previous question to answer this one. Hence, therefore, thereafter. Okay, and if we look at the previous question, they are connected. These two simultaneous equations is almost the same. If we just look carefully, what they've done is they've replaced p. This is not working. Okay, they've replaced p for sin u, and they replaced q for cos v. So from that, hence, therefore, we can deduct that sin u, let's move down a bit, sin u is equal to p, because we replace it, and we know that p equals 0.5 from our previous question. And then that cos v replaced q, so cos v equals 1. So what's left to do now is to solve it. So we want to know what u is. We need to move that sin u to the other side, which means we use the inverse of sin. So on our calculator, we press shift, sin 0.5 bracket equals, and we get the value for u. which is an angle, 30 degrees. Okay. Now, there is something else here. We can clearly see there's another value for u. Okay. And they tell us use between 0 and 360 degrees. So we got 30 degrees. That's one correct answer. It's between 0 and 360. But there is something else. And for this, we need to remember what the sin graph looks like. So there I got the sin graph. And if we look on there, okay, if we go from 0.5 is what it was sin equal to, and we go down, okay, that there would be 30 degrees. Can you see that? Okay. But if we go across at 0.5, we reach again another position. We cross the graph again, and we need to find that value there. Okay. Now, because the sin graph is symmetrical, this distance here from 0 to 30 will be the same distance here from 180 in this direction, again 30 degrees. So yes, to find that new point, we need to do 180 minus 30 because we're going down from 180. So to find our second value for u, we need to do 180 minus 30 equals 150. So that's the other value. Okay. Do we know this is right? Yes, because sin 30, if we type that into our calculator, sin 30, we get a half, 0.5. Just like we wanted there. And if we type in sin 150 into our calculator, again, we get a half, just like we said before. So that's correct. Now let's do the same for the cos. Okay, to find v, we need to do the inverse of cos minus 1, 1. So shift cos minus 1, 1, and v equals 0. Okay, is 0 a viable answer? Yes, because v is bigger than 0, including 0, that little line underneath. So yes, we can use 0 as an answer. But again, there's another value. And for this, we need to look at the cos graph. So here we have the cos graph, where cos equals 1. Where cos equals 1 is where it is 0 degrees. Where does it equal 1 again? Easy as that, at 360. So there's no working out here to do. It's just write down the answer, 360. That's where it is at. Is it correct? Well, first of all, make sure your zeros doesn't look like sixes. They look like zeros. Okay, let's see. Cos 0 degrees on our calculator. Cos 0 equals 1. Sweet. And what does cos 360 degrees equal? Cos 360 equals 1. Sweet. We know it's correct. Well done. Question 4, a mountain of functions to do. This is going to be fun. Right, first of all, find the function of f2. So if you look there, what they've done is they have just substituted the x for a 2. So the function of f2, we substitute that x for 2. So it's 2 times 2 minus 1, 4, minus 1 is 3. Next one. The function of g, let's write that down. The function of g is 3x minus 2. And then inside the function of g, we put the function of f. So instead of x, we put the function of f, which is 2x minus 1. And then also, they have changed the f for a 2. So we change that x, the f, the x for a 2. Okay, you see that's basically the previous answer put into the function of g. So that will give us 3 times 3 minus 2, So that's 9 minus 2 is 7. The inverse of g, one way of doing this is setting it equal to y, the function of g. Then rearrange it to make x the subject. So first we add the 2, then we divide the 3. And remember, in your final answer, just swap back that y for an x. So the answer is x plus 2 divided by 3. So far, so good. Question C. Find x when h, x, so let's write it down. Function of h is 1 over x. Of course, x cannot be 0 because you can't divide anything by 0. Then the function of j, which is 5 to the power of x, but there I've changed the x for a minus 2, so we do that, we do the same, change that x for a minus 2. So let's find x. Right, I think first of all I'm gonna get rid of that index, the 5 to the power of minus 1. So what is it actually, right? Let's put the 1 over x. Anything to the power of a negative we can write as a denominator, so that will be 5 squared. 5 to the power of minus 2 is the same as 1 over 5 squared. Also, we know what 5 squared is, of course. It's 5 times 5, so that's 25. Okay. Next thing, let's get rid of these fractions. I can take the 1 divided by the 25, multiply the 25 there, so that we 1 times 25 is 25. This x multiplied on the other side, 1 times x is x, and bam! Oh, there it pops out as x equals 25. Well done. Question 4D. Function of x minus the function of h as a single fraction. So let's just start by writing down the function of f, 2x minus 1, minus the function of h, 1 over x. Right, vale. Now we need to squeeze this together as a single fraction. So let's first of all make the first one a fraction. Make it a fraction by putting it over 1. So now we got two fractions we can subtract from each other. Okay. When we add separate fractions, we need to get the denominators the same. Let me do a quick example. Let's say we got a half minus a third. Okay, first thing we're going to do, we're going to multiply these together. 2 times 3 gives us a common denominator of 6. Because I multiplied this 2 by 3, I need to multiply the top by 3, so that will be 3. And because I multiplied this 3 by 2 to make it 6, I need to multiply that by 2, which gives us 2. Okay, so basically, we multiply the two bottom ones, we multiply there by 3, and multiply there by 2. So let's do the same here. Okay, first we're going to multiply the denominators together, which is easy, it's 1 times x. Okay, because we multiply this side by x, we're going to multiply that by x. We need to multiply everything by x, so it's 2x minus 1, everything multiplies by x, like we use brackets. And then we need to multiply this side by 1, because basically it stayed the same. Don't forget that minus, and then 1 times 1 is 1. Looking good. Now we just need to simplify it. Okay, let's expand the bracket. X times 2x is 2x squared. X times minus 1 is minus x. That minus 1 is still hanging around at the back, just for fun. And that looks to me like a single fraction. And that is it. 2x squared minus x minus 1 over x. Well done. Question 4e. It tells us find the value of function of j, the function of j where x is 2. So let's first write down the function of j, which is 5 to the power of x. Okay, then in that we put the function of j. So instead of the x, we put 5 to the power of x. But they've also told us what x is. They told us x is 2. So 5 to the power of 5 to the power of 2. That's what we need to work out. So let's first do 5 squared. 5 squared, of course, is 5 times 5 is 5 to the power of 25. Next, 5 to the power of 25. Yes, that's going to be a massive number. Calculator and slot it in. So we've got 5 to the power of 25. Bam. And that's a big number. It doesn't fit on a calculator screen. That's why they give it to us in standard form. But don't be scared. We just write it down. So it's 2.980, etc. times 10 to the power of 17. That's it. Don't be scared. So three significant figures. They will be 2.98 times 10 to the power of 17. Well done. Question 4F. Now, this is difficult to explain without logarithms. Logarithms is not in the exam. So I'm not going to use logarithms. I'm going to try to explain it without logarithms. Okay. The function of j is 5 to the power of x. So let's write that down. The function of j is 5 to the power of x. Finding the inverse of that is another story. So let me give you another example. Let's make up another function. All right, let's call this function m, just for fun. Function m is 5x, 5 times x, not 5 to the power of x. Okay, meaning the inverse of m would be y equals 5x, divide the 5, swap the x and the y, that would mean it's x over 5. See the inverse. Instead of multiplying, now we're dividing. Okay. If I now tell you that the inverse of m x equals 4, like we did in the question F, it means that will be equal to x over 5. So what would x be? We will multiply the 5 on the other side and we'll get x is 20. Can you see what's happened here? What in effect has happened is that we had the same here. We got 20. So the inverse, we can swap the x for a 4, which means to get the inverse answer, it's like getting the straightforward answer for 20, because we're effectively swapping the x and the y values. I hope that makes sense. So you see the inverse equal to 4 is the same as x swapped for 4. Meaning, here, if we have the inverse of x equals 4, swapping the x and the y, which means it's having the function j, the original, and swapping that x for 4, which means that is 5, which is to the power of x, which is now 4, which will give us the right answer. 5 to the power of 4, 625. So to put that again, when we're working the inverse, we're swapping the x and the y around. So inverse function of j x equal to 4 is the same as the function of j where x is 4, which will be 5 to the power of 4. And that's it. Question 5a. ABCDFGH is a regular octagon. So what do we know about regular octagon? First of all, we know, of course, an octagon has got 8 sides. Okay, we can work out the angles in a regular octagon by using the formula number of sides minus 2 times 180. If you forget, why is that the formula? So if we got a octagon, if we take a regular octagon like this one, inside fits exactly, let's see, 1, 2, 3, 4, oh, one more of course, 5, 6 triangles. Yes, and each triangle is 180 degrees. 6 triangles, exactly 2 triangles less than the number of sides. That's why the formula is number of sides minus 2 times 180, which is 6 times 180. All the angles in a regular octagon adds up to 118 because all 8 sides are the same size. If we divide it by 8, we get the size of each interior angle, meaning over here this is the interior angle of this octagon. That's 135. Okay, now what other information do they give us? They say the side length is 6 centimeters. Yep, that's right, that's 6 centimeters there, and shows us a part of it. O is the center, M is the midpoint of AB. Show that the angle OAM, so that means this angle here, OAM, this angle here is 67.5. Now we already got the whole angle there, 135, and because O is the center and the shape is regular, it cuts that angle exactly in half. So yes, that is interior angle is 135. If we divide it by 2, that of course will give us 67.5. So we got our first 2 marks in this question there. Okay, so let's update. Right, next, calculate the area of the octagon. Now, if we can find the area of this triangle and then simply multiply it by 8, because there's 8 triangles will make up this octagon, then we will be able to find the area of the octagon. Okay, to work out the area of a triangle, we need to do half base times perpendicular height. So in this case, we got the base of these triangles, which is 6. We just need to find the perpendicular height, which is this one, OM. Okay, now find OM. We've got a right angle triangle there. You see it? Okay, in that right angle triangle, we've got the length AM, which is 3, as M is the midpoint of that 6, and we want to find that over there. Okay, right angle triangles, we can use one of 2 things. We can use Pythagoras, but Pythagoras only works with the sides, no angles. If we're using angles and sides, we use SOHCAHTOA. For that, we need to label our triangle. So we have this angle here, 67.5. We want to know the opposite side, and we have the adjacent side there, which is 3. We're not working with a hypotenuse in this case. So O and A means we use the ton ratio. So let's write that down. We use the ton ratio, then we put the angle, which is 67.5, equals O is first, put that at the top. O is what we want to find. In this case, I'm going to label it OM. The opposite is the line OM over the base there, which is 3. Okay, so to work out OM, we just need to multiply the 3 on the other side. So OM will equal 3 times tan 67.5. Put that in. And there we go. This gives us 7.2426. Don't round this answer yet. It's not our final answer. It only gives us the height of the triangle. Now we need to work out the area of the triangle, which is called half times the base. And this time we're doing the whole triangle. So the base is 6 AB. 6, not 3, 6. And the height is what we just worked out. On my calculator, I should still have the full previous answer, so I just times that by 6 and times that by a half or divided by 2, and I get the area of one triangle. Again, no rounding yet. How many of these triangles fits into the octagon? 8, of course, so we take that number and we multiply it by 8. Have it there, just times it by 8, which gives us a nice 173.82. And now on our final answer, we can round it to 3 significant figures, 174 centimeters squared. Question 5b, part 2. The area of a circle that passes through the vertices of the octagon. Alright, can we imagine what that looks like? Okay, it will be like a circle that comes around like this, something like that, yeah? Meaning that the radius of the circle would be the side of this triangle, or rather the hypotenuse of that triangle we had before. Now remember, in that triangle, well, we worked out OM, but I think to be more accurate, I'm going to use the values that they've given us. So I'm going to use the 67.5 and the 3 again, and this time we are using the adjacent and the hypotenuse. So that will be K. We're using the cos ratio to work out the hypotenuse of that circle. So that will be cos 67.5 and then it's the adjacent, we was 3 over the hypotenuse, which is the radius of the circle, or other words, AO or OA, the length of that line, that's the hypotenuse. So to work OA, I'm going to multiply it over there and then divide cos 65 on the other side. So we're basically just swapping them around. So to work out OA, it's 3 divided by cos 67.5. So OA, let's type that in. So the radius of that circle, or the hypotenuse of my triangle, is 7.839, etc. Again, don't round. Now remember, we're working out the area of a circle. The area of a circle is pi r squared. So it's going to be pi times 7.839 squared. Take this, we got it, square it, and then we multiply it by pi. Okay, and that should give us the right answer. 193.06, rounded to 3 significant figures. 193, which is close to our previous answer, but not exactly the same. Question 5b, part 1. The volume of the container. Now that is a prism. A prism with a cross section of a semicircle. So to work out the volume of a prism, you first have to work out the area of the cross section. Right, so this is a semicircle. So first work out the area of a circle, remember. is pi r squared. Semicircle is just half of that. This semicircle's got a radius of 0.45, so it will be pi times 0.45 squared divided by 2. Let's hammer that in. Right, so that will give us 0.318, etc. meters squared, of course. Now, to get the volume, we need meters cubed, so we just take that 0.318 meters squared and multiply it by the length, which is meters, gives us meters cubed in the end. So keep the whole unrounded answer, times it by 4, gives us 1.272, etc. Rounded to 3 significant figures, 1.27 meters cubed. Question 5b part 2. 6 marks. This is a challenging question. Let's start to write by writing down what we know. We know that the radius of this pipe from there to there is 0.45 meters. They have given that to us. Meaning if we lower that level of the tank is 0.3, we know that this is 0.15, because that line there forms a radius as well, which is 0.45. Subtract the 0.3, we get 0.15. Okay. Do note very carefully, we don't know this. Come on. We don't know the value of this line. Okay. It is less than 0.45, more than 0.3. But we can't make any assumptions. Okay. Now, after thinking this through thoroughly, I thought it would be best to work out the area, the area up here of this. Once we got that area, we can work out the area of the empty space and subtract it from the volume over there that we do know, the volume of the whole thing, and then we'll have the volume of the water in the tank. Okay, so how do we find this? This is not a regular shape. So let's make this into two shapes. We can work out the area. Okay, first of all, if I draw a line like this, this forms another radius. Another radius with also a length of 0.45. I have now divided that into a sector and a right angle triangle. So let me we'll put this into colors, right? Here we have a right angle triangle, and over here we've got a sector of a circle. See that? And I know how to work out the area of a right angle triangle, and I know how to work out the area of a sector. We just need to gather all the information we could possibly gather. So let's start with that right angle triangle. Okay, what can we do? Right angle to the area of a triangle. Let's write that down. Area of a triangle is half base times height. Okay, we don't have the base here, but we got a right angle triangle. Remember, right angle triangles, if we work just with the sides, we use Pythagoras. If it's sides and angles, we use SOHCAHTOA. In this case, To find the base of that triangle, we've got here the hypotenuse and we've got another side. So to find the length, the base of that triangle, let's call it B for base, will be the square root of the hypotenuse, 0.45 squared, minus the other side we have 0.15. Let's put that in. Okay, now we can put down all these decimals, but I want to keep it accurate. So the base of this triangle is 3 square root 2 over 10. Okay, let's put it in there. Excellent. Okay, so the area of that triangle is half all this jazz we just got. Make sure we copy it right. Times the perpendicular height, which is 0.15. Let's put that in. We put answer, insert, of course, the previous answer. Okay, and we can't simplify this, so we just put as many digits as possible to make this accurate. At least 4 significant figures, but of course 5 is better. Right, the area of the triangle in red, we've got that. Now let's find the area of the sector. Okay, and remember the area of a sector is the angle divided by 360. That gives us the fraction of the circle times the formula for the area of the circle. Okay, do we have that angle? I'm afraid at the moment, no. Okay, but what do we have? What do we have? Stay calm. Okay, we've got a 90-degree angle here. And using SOHCAHTOA, we can find that angle there. Alright, so just label our triangle. From that angle, I'm going to use the hypotenuse because it's a clear value we have. And I'm going to use the adjacent. Okay, so I don't have to use that complicated 3 square root 210. I don't have the opposite. I can use it, but I don't have to. So that would be safer. So that is the cos ratio. So let's do that. So we're going to do cos that angle. Let's call it angle X equals first the adjacent 0.15 over 0.45. So that means X equals the invert of cos 0.15 over 0.45. Put that into a calculator. Okay, again, let's put at least 4 significant figures, if not more. Having found that, we can now work out the angle there, the angle of our sector. All we need to do is subtract it from 90. And there we go. That angle there is 19.471 at least. So I can now go back down here and work out the area of that sector. Okay, so that was 19.471 over 360. times pi times the radius, which was 40.45 squared. So having that still on my calculator, divided by 360, then times it by pi, times it by 0.45 squared. Back. Okay, so we got the area of the sector. Okay, my next step would be to find the whole area of the blank space above. Let's do so this whole area. Yeah. So what I'm going to do, I'm going to add the area of the sector, the area of the triangle, and multiply it by 2, so I got everything together. So that was area of the triangle 0.031819 plus the area of the sector 0.034408, and then times it by 2. Okay, so got that still there. Let's add the 0.031819. Press equals before we double it, because our split mass applies. And we have now 0.13245, etc. Remember, now this is meters squared. Now, to find the volume of that blank space above the water in this semicircle square trough, we now need to multiply it by the length, which is 4. So if I take that value, 0.13245 times 4, I will have the volume. The volume of that is 0.52981, etc. meters cubed. Next step, find the volume of the water. We have that there. Previous answer. In fact, let's use a little bit more accurate. That one, 1.272. So the volume of the whole thing, 1.272. Subtract the volume of the blank space above. So 1.272. Subtract our previous answer equals 0.742218 meters cubed. Whew, things are looking good. We're making progress. Last thing they want us to do is give the answer in liters. Okay, gotta now convert that to liters. How do we convert meters cubed to liters? So what I usually do, I just remember one thing. If you would take a cube, and this cube is 10 centimeters by 10 centimeters by 10 centimeters, which gives you 1,000 centimeters cubed. That equals 1 liter. 1,000 centimeters cubed equals 1 liter. Okay, so first of all, let's change our value here to centimeters cubed. So 0.74218 meters changed to centimeters would be times 100. But because we are cubing, we need to cube this factor. So I take my answer there and times it by 100. cube. Bam. Okay, so that's what we have. 742,180 centimeters cubed. To change that to liters, we need to divide it by 1,000. So we divide that by 1,000, which will give us 742.18 liters. Rounded to three significant figures, 742. Final answer. Okay, 6 marks, quite a challenge, but believe in yourself and then you'll be. Question 6a. They give us there a cubic graph and then start again. Right. Question 6a. They give us there a cubic graph and the first thing they ask is, well, it tells us the function f, find f bracket 2. Alright, so what have they changed? They've changed the x there for a 2. So all we need to go is go on the graph where x is 2, then use the graph with a ruler and a pencil to find the value of y. What does it equal to? We go down and we go across accurately as possible. There we go, minus 3. Question 6a part 2. Now they said solve the equation the function of x equal to 0. So what has changed here? You see, before the function of f was equal to y, now it's equal to 0. From that reduce where y equals 0. On the graph, where does y equal 0? Well, there on the x-axis. Everywhere here, y equals 0 on this line here. Okay, so where does that line cross the graph? That's what we need to deduce. Okay, so simply fills plain English, where does this graph cross the x-axis? Because that is where y equals 0. Over here, first one here is exactly at minus 1. Second spot, it crosses is there. There are 10 squares between each value, so each square counts for 0.1. So we get 1.1, 1.2, 1.3, 1.4, 1.5, 1.6. On the mark scheme, it says 1.55 is also correct. And the last one here, 4.1, 4.2, 4.3, 4.4, 4.45 is also correct. Just 4.4 is good enough. Right. Next one says the function of x equals to k. Remember, before it was equal to 0, horizontal, we had 3 solutions. Now it's equal to k. K is an integer, which means a whole number. No fractions, no decimals. Find the smallest number where it has 3 solutions. Okay, so first of all, if k was 8, that means we would have had a line going through 8. Like this. And we'll have 1 solution. Okay. If k was 7, it looks like, maybe not exactly, maybe a little bit more than 7. Right? We might have had 1, 2 solutions, or maybe 3. Like if k was 5, which y equals 5, we would have had 3 solutions. So what they're asking for is, what is the smallest integer where we have 3 solutions? So we go down here, and if you look here, if we draw a line going through minus 8, that's the smallest one where we'll have 1, 2, 3 solutions. When we get to minus 9, we will only have one solution over there. The answer here is minus 8. It's the smallest integer where we'll have, okay, 3 solutions. Next one. On the grid, draw a line. Y equals mx. Now remember here, usually it's y equals mx plus c. What's happened to that c? That c is the y-intercept. Okay, and it's pulled away. Why? Because it must be 0, which means this line is going to have to go through 0 on the y-axis. Okay, so we got 1 point on that line already. Goes through there, 0, right in the middle. Okay. So that is exactly one solution. That's what we're looking for. One solution. So we go back here. We need to draw a line. Goes through the center where we have one solution. Okay, there's more than one options. Okay, first of all, this would be wrong if I'm going to draw a line. Goodness. Okay, let's try that again. This will be wrong because this line now has 3 solutions. Crosses the graph 3 times. Okay, so a possible correct solution would be, okay, if we were to draw, let's say, a line. This is going to be a tough one. Going like this, yeah. There's a possible correct solution. As you can see, this line only crosses the graph once. That's for a positive gradient. Okay, does it say the gradient has to be positive or negative? No. So another possible solution would be going the other way. I like this one more. It's clearer. And there we go. One solution crosses the graph once, goes through the center. That's how you get that mark. 2 marks rather. You've done it. Question 6b, differentiation. Right, first of all, they ask us to find the value, which means the gradient, when x equals 5. First thing we need to do is we need to differentiate that graph. So remember differentiation, we multiply the index with the coefficient in front. So 3 times 2 is 6. X, yeah, this will be d over dx. And then we subtract 1 from that 2. That gives us 1. We don't have to write that 1. It will just be 6x. Okay, over here, imagine there's a 1 there. 1 times minus 12 is minus 12. Subtract the 1 from that 1, which will give us x to the power of 0. Anything to the power of 0 is 1. 1 times minus 12 is minus 12. So that means that drops away. Okay. The plus 7, of course, falls away. If you want to imagine what we're doing here, it is, imagine there's an x to the power of 0, which is 1. 0 times 7 is 0. 0 is okay. That means that's why it drops away. That's it. All right, what it told us now, when x equals 5. So we substitute the 5 in there. So that will be 6 times 5, which is 30, minus 12, gives us the answer 18. That means the gradient at that point is 18. Okay, very steep gradient. Then it says find the coordinates of the point on the graph where the gradient is 0. Now remember, 3x squared minus 12x plus 7, of course, is a parabola. It's quadratic. Okay, so there it is. So where is the gradient 0? Of course, where the turning point is. What would that be? That would be where y equals negative 5. Okay, that's it. See, that is it. And there's the coordinates. So that's it. That's it. Somewhere. Oh, there we go. That's the answer. Keep it that 2 minus 5. Got the answer already, but you won't have Desmos graphing, so we're gonna use math to do it. All right. That means when the gradient is 0, dy over dx is 0, so it means all of this is equal to 0. So we set it equal to 0. And then we solve it. So that will be 6x equals 12. Divide the 6 the 12 by the 6, x equals 2. There we go. Finding the y value, we substitute that into the original equation to get that y value there, yeah? So it's y equals 3 times 2 squared minus 12 times 2 plus 7. Okay, hammer that into your calculator quickly, and that gives you minus 5. Remember, that's what I showed you on the graph. Question C, they just kind of see if we can do differentiation backwards. Okay, want us to find P and Q. So first of all, P, when I multiply that P with a 2, I get 14. So basically, P times 2 equals 14. What times 2 equals 14? That's 7. Okay, we know it's right because the next step of differentiation would be to subtract from that 7 1, and then we'll get a 6 over there. So that's correct. Okay, next part here. There we go. Now we multiply that 2 with a q. So you get 2 times q. What do we get? We get 6. 2 times what is 6? That, of course, is 3. We know it's right because, because 2 times 6 is 3. That's it. And then 2 minus 1 is 1. That's it. Got it. Done it. Well done. Question 7. We got triangles. Triangles, trigonometry. Whenever we work with right angle triangles, we can use Pythagoras. If we are working with sides, if we're working with angles and sides, we use SOHCAHTOA. But we don't see any right angle triangles at this moment. That means for any other triangle, it's not a right angle triangle, we use either the sine or the cosine rule. Right, so first of all, calculate angle ACD. Let's mark that. We go from A to C to D. This is this angle here. Right, sine or cosine rule. For the sine rule, we need an angle. If you look at this 123 here and that 14, that's a classic sine rule triangle. We've got an angle on the opposite side, that we'll use a sine rule. But when we only have side lengths, no angles, the only option here is to use the cosine. Cosine rule, we work with sides. Okay. If you want to work out an angle and a cosine rule, we use the rearrange formula, which is this one. Let's write it down. Okay, so the rearrange formula for the cosine rule will be cos the angle, then b squared plus c squared minus a squared, reminding of us Pythagoras, over 2ac. Okay, in our triangle above there, what is A, what is B, what is C? Now we got an A, a D, and a C in this one, so I'm just going to rename it. Okay, A would be, of course, the angle we want, meaning the opposite side there will be the lowercase a. The other two sides doesn't matter. Okay, B and C in any order. We can make that B and that C, or we can swap them around. This doesn't matter as long as we got the A in this case correct. So let's start. Now to work out angle A, I'm going to straight from the start rearrange it and move that cos across. So we got the inverse of cos. B is 12 squared. We could have put 14. C is 14 squared. We could have put 12. But what's important is that A is 9 squared. That has to be 9. Can't be anything else. Then 2 over A. Yeah, see, that's wrong. That shouldn't be AC. It should be BC. Because it's those two values that doesn't matter. 12, 14, 14, 12. All that's left to do now is hammer that into our calculator. So shift, cos, fraction, 12 squared plus 14 squared minus 9 squared over 2, 12 and 14, close bracket. I've got an answer. 39.57, 1, etc. Rounded to 1 decimal place, as this is an angle, 39.6 degrees. Question 7b. Show that BC equals 7.05 kilometers. Correctly 2 decimal places. We can see that. BC. So let's clear this clutter. BC 7.05 kilometers, I presume. Yes. Okay. So as I said before, this is not a right angle triangle, so we're going to use the sine or the cosine rule. Now looking at that, classic sine rule questions, we have an angle and the opposite side. Once you see that, an angle on the opposite side, you know we can go for the sine rule. Okay, because we're going to use that angle on the opposite side to find and use this angle and that opposite side to find BC, which we need to show at 7.5. Okay, now we always start by writing down the side we want to know. In this case, it's BC. We want to calculate or show that BC is 7.05. So it's BC over sine, and the angle that's opposite BC is over here, 25 degrees. Putting that unknown at the top as a numerator just makes calculation later on easier. You can put it at the bottom, you can put the sine at the top, okay, but this makes it easier. Right, then we take a side we have, which in this case is 14, over sine the angle opposite 14, which in this case is 123. Now to calculate, we simply need to multiply that sin 25 on the other side. So that will give us BC equals 14 times sin 25 over sin 123. Right, there we go. Calculator, fraction, close the brackets, add back, and it all looks very good. Okay, it's important because it's set correctly 2 decimal places, and we're showing it is that we write the unrounded answer and then we round it, showing that I've rounded it to correctly to 2 decimal places. Okay, that part is important. It counts marks, showing the unrounded and then the rounded answer. Question 7c, calculate the shortest distance from B to AC. Let's go back up there. The shortest distance from B to AC. Now the shortest distance can only be one thing, and that is a perpendicular line. Okay, so perpendicular means we got 90 degrees. So 90 degrees, which means we've got a right angle triangle. What do we have in that triangle? Well, we got what they've just told us. BC is 0.05, and we got this angle that is 32. We got a right angle triangle, which means we're going to use Pythagoras SOHCAHTOA because we're involving an angle SOHCAHTOA. So let's label the sides of this triangle. Okay, the 7.05, of course, is the hypotenuse, and we want to know the shortest distance between B and that line, which means it is the opposite side here, O. So H and O is what we're working with from that angle 32. O and H means we're going to use the sine ratio. So let's write that down. Okay, first of all, it's going to be sine the angle, which was 32 degrees. Then is the opposite, which is that distance we want to know. Let's just keep calling it opposite, over the hypotenuse, which was 7.05. So to find that opposite side, you need to multiply that 7.05 over there. Do that. Gives us 3.7359, etc. Rounded to three significant figures, 3.74. Question 7D. Calculate the length of the straight line BD. So we go back here and we draw the straight line BD. So that forms triangles. None of them are right angles. So again, sine or cosine rule. What do we have? Let's see. If we go to the triangle on the right, I have quite a few information. Okay. We have, start off, we've got two side lengths, 12 kilometers and 7.05 kilometers given to us. And we've also worked out 39.6, which give us this angle here, which would be 71.6. So I got two sides and one angle. All right, again, I don't have any opposite. I don't have a side and opposite angle. 12 kilometers, the opposite angle, I don't have that. It's not 123. 7.05, I don't have that angle there. And I don't have this side BD, which I need to calculate. Okay, so it means we can't use the sine rule. Don't have any of the opposites. So obviously, we're going to go for the cosine rule. Okay, cosine rule, and in this case, the straightforward cosine rule. There we go. So let's write that down. Cosine rule is, there we go. Start a squared equals b squared plus c squared. Pythagoras, nice, yeah? Minus 2bc cos a. Now what is a, what is b, what is c in my triangle up here? Okay, first of all, I'm going to make a the side I want to know. This one here. That means capital A is the opposite side here. That will be capital A. The angle is 71.6. Then again, as before, B and C can be in any order. That B and C, any order. So we're going to start with that. Right. So, first of all, BD is A. So A is BD. Let's write that down. What is it? There it is. Okay. BD is A. Now again, speed things up. That square there, I'm going to immediately move it to the other side. So we do that. All right, then B, remember we said B is 12 kilometers. So that will be 12 squared plus C. C is the other side. We made it 7.05. Remember, you can swap these two around. It doesn't matter. Minus 2. Then again, B is 12. Again, C, 7.05. Cos, let's extend that line. Capital A is that angle There, which we figured out 71.6. So that means BD, we can put it into our calculator exactly like that. Square root 12 squared plus 7.05 squared minus 2 and we get a nice 11.8446, etc. Rounded to three significant figures, 11.8. Question 7e. It tells us C is due east from A. Why do they tell us? All right, of A. Why do they tell us? So what does it mean? Okay, this is talking about bearings, of course. Bearings means that straight up north is always 0, 0, 0. North 0, 0, 0. That means the bearing of C from A is 0, 90, 90 degrees. This is 90 degrees. That's what it tells. It's important. Okay, then it says, what is the bearing of D from C? So you need to clearly remember here, we're now at C and we want the bearing of D. Remember the rules of bearing. First one we just mentioned, that north straight up is always 0, 0, 0. Second rule of bearing is we always go clockwise. Always go this way around. So the first thing I want to say is the bearing of A from C, what would that be? That would be this. Whole angle here will be 270 degrees. Now to go from C to D, this part here, okay, would of course be just another 39.6 we need to add on. So our final answer here would be bearing of D from C, 270 plus that 39.6, which of course will give us 309.6 degrees. Question 8, Venn diagrams. I love these. Right, use set notation to describe the shaded region in the Venn diagram. Okay, remember now the most two important things, Venn diagrams. We have union and we got intersection. Union means the one or the other or both. For me, it's always lead. Intersection has to be in both. I call that erase. You'll see why. Okay, first of all, the first one here, we got a gray area there, and it is an A, and it is in B. Okay, but it's not the one or the other. It is in both. Okay, so it means this part here and this part here, that has been erased. This is intersection. Intersection means in both, not just the one or the other. Okay. Using that information, we go on to the second one, the one below. Now we'll see how this becomes helpful. All right. First one, Q union with the complement of P, which is not P. So first, let's just start by marking Q. This is Q. Everything that's in Q. Then let's highlight the complement of P. Everything that is not P. And then we think, are we going to raise anything or are we going to leave it like it is? And because it's union, it means in the one or in the other one or both, we leave it. Don't erase anything. That is the answer. Okay. Don't do what I've just done. That is not how you leave it. Final answer, you color it in. Don't draw lines, you color in. So what it needs to look like when you're finished is like this. Yeah, very clear, nice. I'm sure you can do it better than I do. Make sure it's accurate and nicely shaded in. Okay, going to the next one. Just like bitmaps, let's start with K union L. So let's first highlight K, and then we got L, and then we ask ourselves, do I erase or do I leave it? It's union, it means in K or in L or in both, we leave it. That's it. Okay, for now. Then we go to the next part, which is intersect with the complement of M. So this time let me use a different color. Let's shade everything that's a complement of M. So that means everything that is not M. And again, we ask ourselves, do I leave it or do I erase anything? And this time it's intersection. It has to be in both. Okay? So this time we are going to erase everything that is not overlapping. So I only leave where I've, in this case, got the orange and the blue, everything overlapping. So my final answer will be only this part where they overlap. And everything else gets erased. That's it. With practice, you can get good at it and you can do this. Question 8b, some probability. We got 11 cards. How many of them are not A's? Well, there's 2 A's, so there's 9 of them that is not A. All right. Part 2, a card is chosen at random and then it is replaced. This is very important. They put back the card. So every time they pick, there is 11 cards. A second card is then chosen. Find the probability that exactly one card has the letter N. Okay, let's think about this carefully. The first time we pick a card, let's imagine that's an N. What is the probability of that happening? Well, how many N's are there? There is 2 N's. Okay, so the chance of picking a card that is N is 2 out of 11. Put it back, and then we pick another card. And this time, it can't be an N, because we need exactly one N. So it has to be one of the other 9 cards. So that's 9 out of 11. Okay, so for this to happen, we have to pick an N and then pick another, not N. That's the AND rule. And for the AND rule, remember, we multiply them together. Okay, so that will be 18 out of 121. Okay, but there's another thing that can happen. We can pick a card that's not an N first. What's the chance of that happening? 9 out of 11. And then pick the N, which is 2 out of 11. So that will also be 8 out of 121. Okay. Can these two things both happen at the same time? No. It's either the one or the other. Either we pick first the N or we pick second the N. The OR rule means we add. So it means we're going to add 18 over 121. Add these two probabilities together or just multiply it by 2, whichever you prefer. Either way, in the end, it will give us 136 over 121. Okay, if you want to simplify it, if you can, you can, but that's good enough. Question 8c, and you thought you were finished with Venn diagrams. They gave it back to you. Right. 50 students are asked if they like English and if they like maths. Okay, that means our universal set, everything in that box needs to add up to 50, because that's how many students were asked. 3 say they do not like English and they do not like maths. Okay, so those 3 is in the box but outside the ovals. Okay, so remember that now, that all the English and math students, the one that like the one or the other or both, they need to add up to 47. Okay, 33 say they like English. Now, of that 33, we don't know yet which of them likes math. So I'm going to put this 33 there. It's not part of my answer. I'm going to rub it out later. But we know in that whole oval, there should be 33. 42 say they like mathematics. The same thing. In this oval, it should add up to 42. But we don't know which ones of those likes English as well and which just likes maths. Okay. So, what does this tell us? Well, there's 33 liking English. There's 42 liking maths. And that adds up to what? 75. Which seems weird because I just told you up there it should add up to 47. So how many too many is there? 75 minus 47. Of course, that will give us, what's that? 28. 28 it is. Yeah. 28 too many in those two circles. Why is it 28 too many? Because 28 of them is being counted double. Why are they being counted double? Because they like both. That 28 too many is the ones that goes into both English and maths. So when we count them for the English and then we count them for the maths again, we counted them twice. That's why there's too many. All right, so now that we know there's already 28 in the English circle and it should be 33, there is only 5 that only likes English. And since we know there should be 42 in the maths oval, but there's already 28, that means we are 14 short there. Okay, so 28 plus 14 is 42, 5 plus 28 is 33, 5 plus 28 plus 14 is 47, 5 plus 28 plus 14 plus 3 equals 50. Now we know it's correct. Everything makes sense. Rub out anything that's not part of your answer so that it is clear what needs to be marked. Right, now again, a little bit of probability. A student is chosen at random. Find the probability that the student likes English and likes maths. So we know there is 50 students. 28 of them likes both. You can simplify if you want. You don't have to. They didn't tell you have to. So that's good enough. 350. All right, next, we're choosing 2 students. Find the probability they both like mathematics. So picking a student that liked mathematics, there were 42 of them, remember? Okay, yes, some of them like English as well, okay, out of 50. Now, we're not going to pick the same student twice, so the next time we pick a student that likes maths, that will be 41 of them left and only 49 students. Again, this is the AND rule. This, and then we pick that one, so we need to multiply it together. For this, we grab our calculator. Okay, if you hammer into your calculator, it would simplify it immediately already. 123 over 175. But you can also write the unsimplified answer, which will be a lot bigger. Okay, just use your calculator to speed things up. Okay, part 4, 2 students who like English. It's amazing how many students in the exam, it just ignores that part, right? 2 students who like English. That means now we're only picking from the English students, and that was 33. There were only 33 of them. Okay. So we're picking from 33 students now. Find the probability that they both also like math. So of those 33 students who like English, 28 of them like maths. Okay, so to pick one of them, we need to pick 28 out of 33. But then again, okay, the next one we pick, there are going to be less. There's going to be 27 students left who likes English and maths, and there's only going to be 32 students left who likes English. So it's the one and the other again. And again, grab your calculator, hammer it in. 63 over 88. Question 9a. It tells us the area of the rectangle is 29 centimeters squared greater than the area of the square. Okay, so what is the area of the square? Well, the area of the square will be x times x. Let's write there the area. X times x is x squared. Brilliant. Now the area of a rectangle is 29 more. So that means the area over here is x squared, same as the square, plus 29. Okay. But hey, there's another way to work out the area of the rectangle. Multiplying the length and the width together. So that meaning if I do the length, 2x plus 1, multiply it by the width, x minus 1, I will get the area of the rectangle, which we've just determined is x squared plus 29. Okay, good. I got an equation. I know how to do algebra. Let's fluff around with that. So, multiply out the brackets. 2x times x is 2x squared. 2x times minus 1 is minus 2x. 1 times x is 1x, which is x. 1 times minus 1 is minus 1. Looks like we're heading here for a quadratic equation, you know. X squared, factorize, get the answer. So let's shove everything to the left. So we got the 2x squared, and from that I'm going to subtract the x squared, since we're moving it across because it's negative. Then I got the minus 2x plus the x. I can work that out. Let's do that. Minus 2x plus x gives me minus 1x, which is minus x. Then we got the minus 1, and we can put that plus 29 becomes minus 29 equals to 0, because now I've moved everything to the left. Simplify. 2x squared minus 1x squared gives me x squared minus x. Minus 1 minus 29, of course, is minus 30. Okay, we're just subtracting here. We're not multiplying. It doesn't become positive. Now we've got a sweet, clear quadratic equation. We can factorize or use the quadratic formula. Well, let's try factorizing first. Okay, so we've got x and x. I need to think of two numbers and multiply together to give me negative 30. So what springs to mind here is, let's use a different color for this one. Okay, 5 times 6, of course, is 30. One of them has to be negative to make it minus 13. I noticed that the other term there is negative, so I'm going to make the bigger one here negative. So when we add them together, 5 plus minus 6, I get minus 1. Good. You see I got the minus 30 there. Add them together, get minus 1, which is minus 1 there. So that means I've got my two factors, which is a positive 5 and a negative 6. We can now solve this. We do x plus 5 equals 0. That means x is minus 5. Or x minus 6 is 0. So x could be 6. Sweet. So what is x? Minus 5 or 6? Well, when it comes to lengths, in this case, there's no negative. So I assume x is 6. Alright, so x must be 6. Good. There we go. X equals 6. We got value of 6. Right, that's all from that first line there. Let's see what they say. The difference between the perimeters of the shapes is okay. So let's work out the perimeters. Right, the perimeter of the first one is going to be longer. This perimeter of the second one is easy. That's x plus x plus x. That's 4x. Okay, the difference between the perimeters. Are we going to assume... Oh, what? You know what was going to be quicker? We just use 6 as x. Put it in there. So if x is 6, then the length of this one is 2 times 6 plus 1. 2 times 6 is, of course, 12 plus 1 is 13. Good, we got the length. Here, x is 6. 6 minus 1 is 5. And here the perimeter 4 times 6 is 24. What's the final perimeter of the rectangle? Well, we're going to be 2 times 13, or 13 plus 13, the 2 lengths, plus 5 plus 5. What is that? That will give us 36 perimeter. The difference between the two is k, so we just have to subtract them. 36 for the perimeter of the rectangle minus 24 for the perimeter is 12. So that is k. K is 12. Okay, that's enough to give you full marks. So just looking at the mark scheme where they give the marks for, and that's it. That gives us a mark. Okay, you get 3 marks for getting up to this point. You get a mark for factorizing. How much is this? 6 marks. You get a mark for x equals 6. You get a mark for 12. Question 9b, part 1. It is very similar to question 9a. Again, it said the volume of the larger cube is 5 centimeter cube greater than the volume of the smaller cube. So what's the volume of the smaller cube? Well, of course, it will be length times width times height. Cube is y times y times y. That is y cubed. So the volume of the larger cube is 5 more, so it's y cubed plus 5. But there's another way of working out the volume of the larger cube, and that's by multiplying the length and the width together, which is all the same. So that means we're doing y plus 1 cubed, which is y plus 1 times y plus 1 times y plus 1. So let's do that. Let's multiply all those brackets out. Okay, just do it slowly, carefully, 2 brackets at a time, so you don't get confused. Y times y is y squared. Y times 1 is y. 1 times y is y. 1 times 1 is 1. Don't lose that bracket at the back. Trail it hanging around. Let's simplify that first bracket. So that will be y squared. Y plus y is 2y plus 1 and y plus 1. Now we're going to multiply everything in the first bracket with everything in the second bracket. Okay, let's bring in some color. So first of all, y squared times y will give me y cubed. Y squared times 1 will give us y squared. Then 2y times y will give us 2y squared, and 2y times 1 gives us 2y. Okay, go through this slowly so you don't get those indices wrong, the squares, the cubes, because that's where mistakes creep in. Last one, 1 times y is y, and 1 times 1 is 1. Okay, so let's add like terms together. We got y cubed is y cubed. Then we got y squared, and y squared will give us 3y squared. And then 2y plus y will give us 3y. And hanging around the back there is a good old 1. This is not where we want to be yet. We're getting closer. Okay. What else do we know? Well, we know that is the volume of the larger cuboid, but also we know that this is the volume of the larger cuboid. So we just need to set that equal to each other. So we need to take this whole equation we just got, y cubed plus 3y squared. This is one here, yeah, of course, plus 3y plus 1. That is equal to the y cubed plus 5. Okay, Make sure that's equal to 0 by moving things across to the other side. So we'll have y cubed minus y cubed. We'll have the 3y squared where it is, then the 3y, then the plus 1, and then minus 5. Simplify that. Y cubed minus y cubed is 0. 3y squared is 3y squared plus 3y. 1 minus 5 minus 4. And we've done it. Okay. So things are looking good. Part 2 tells us find the volume of the smaller cube. Show all your working and give your answer correct to 2 decimal places. Now, correct to 2 decimal places means to me I'm going to have to use calculator. Okay. So what do we have? We got this equation. 3y cubed plus 3y minus 4 equals 0. And we want to know what is y. We can try and factorize this, but we already got a clue that it's got decimal values, so it's completely hard to factorize. So there's only one other thing we can do, and that is use the quadratic formula. So the quadratic formula, remember, well, it's x equals, but since we don't working with y's, we just make it y equals minus b plus minus b squared minus 4ac over 2a. Okay, remember here, a is the first coefficient, so a equals 3. B, second one there, is also 3. And c is minus 4. Let's substitute in those values. So minus b is 3. A is 3. C is negative 4. And A is 3. Right, calculator. And put it in. So fraction negative 3. Let's do the positive first. Square root 3 squared minus 4. 3 negative 4 over 2 times 3 equals. So our one answer is 0.758. Don't round yet. 3, 0, etc. With the negative value, let's go back and just change that plus for a minus. And that gives us a negative 1.758. Okay, so it's being measurements, we're only going to use the positive answer. Okay, what are we actually working out? We're working out the volume of the smaller cube. Here, what's the volume of the smaller cube? Y cubed. So that's easy to do now. We're almost there. So the volume of the cube will be 0.758, etc. cubed. So on my calculator, okay, I'm going to go back. I'm going to get the previous answer on there just by changing that minus back to a plus. See, there it is. I just want to cube that, so all I need to do is cube it. And then we go. Okay. 0.4360, etc. And now we can, of course, round it to significant figures, only at the very end. And we've done it. Full marks. Well done. That's it for today. Please like, please subscribe, and please leave some comments. And I'll see you again soon. Adios.